Let's look at the area of a region between two curves. Suppose I have a curve F and a curve G. If I want to find the area between the curves, then it's quite obvious that I'm going to have to do some subtracting and some integrating. And it turns out that this area right here, we're going to call this big A, is equal to the area under the region of F, or under the region of the top function, minus the region under the bottom function. So we can say that the area between the regions, between F and G, between A and B, is the integral of f of x minus g of x. Now to do these problems, I'm going to want you to give me the sketch, draw your representative rectangle, and then show me delta x, because this is going to translate into our dx. Once you have dx, you can find your limits in x, which are a and b, and then your integral becomes the integral from a to b of f of x minus g of x dx. Now, here are the steps, and I do want you to be careful with them. Make sure you sketch, draw the rectangle, identify the top and bottom, or left and right if we have a horizontal rectangle. Identify dy or dx. Now, if it's dx, you're going to have a top and bottom function, while if you're doing left and right, you're going to have a dy. Now, identify your bounds a and b. If you're doing left and right, these are going to be y values, while if you're doing top and bottom, these are going to be x values. Then write the integral. It's either the integral from a to b of top minus bottom dx, or the integral from a to b of left minus right dy. Let's do an example. Let's find the area bounded between f of x is x squared plus 2, g of x is minus x, between 0 and 1. Now, the first thing, I've already done my sketch. I've given the representative rectangles, so I need to identify that this is going to be delta x, which tells me everything needs to be given in terms of x. So a in this case is 0 and b is 1. So I know this area is going to be the integral from 0 to 1 of my top function, which is x squared plus 2, minus my bottom function, which is minus x, whole thing dx. So this is the integral from 0 to 1 of x squared plus 2 plus x dx. So this is x cubed over 3 plus 2x plus x squared over 2, evaluated at 0 and 1, this whole thing. So when I plug these in, I want to factor out this 1/3. So this is 1 cubed minus 0 cubed plus 2 times 1 to the first minus 0 to the first plus 1/2 times 1 squared minus 0 squared. And if I solve this, it's going to wind up giving me 17/6. Now, another thing I want to point out, areas between curves is always positive. An area between the curves is always going to be positive.